In the first figure, we can see two intersecting lines. Here is one line, and this yellow line is represented by the equation 3x plus 4y equal to 20, which means if we take this equation, you find the solutions, plot them on the graph, and we will get this line. Then we can see yet another line here. We'll mark it in green, the green line, and this is represented by this equation. So x minus 2y equal to 0. Every linear equation represents a line. Now these are two intersecting lines. And how did we know they were intersecting? Because we drew them graphically. Now let's get on to the next second figure. Here I can say one and only one line. Like I have this line. It is represented by this equation. There are two equations here, 4x plus 6y equal to 18, and there is another equation, 2x plus 3y equal to 9. And this second equation is also represented on the same line. Both the lines coincide, one over the other. Now in the third, here again we have two lines. We have this line, the yellow line here, one line, and we have another line. And we can see both these lines are parallel. The yellow line is represented by the equation x plus 2y equal to, I put 4 here, the minus 4 I take on the other side becomes 4, and the second line is represented by 2x plus 4y equal to 12. In the first case, the lines were intersecting. In the second case, the lines were coincident. They were one over the other. They represented one and the same line. And in the third case, the lines were parallel. These are the three situations that we can get if we have two lines. They either could be intersecting, or they could be coincident, or they could be parallel. But in each of these cases, we needed to draw the lines to find out if they were intersecting, coincident, or parallel. Here we will learn a method to find out if the lines are intersecting, coincident, or parallel without drawing the graph. We've already seen earlier in the last session, drawing the graph is a long method. It takes a long time to draw a graph. But we will learn a method to find if the lines are intersecting, coincident, and parallel. First thing we must remember that every linear equation we can draw a line. Now let us examine the first one. Now the first equation is 3x plus 4y equal to 0. Now this is my x term, and my a1, that's the x coefficient, is 3. In the second case, this is my x term, and I write a2 as my coefficient of x, and that is 1. Let's get on to the next. Here is my y term, and I will put this b1 as 4. b1 is a coefficient of y. And in the next case here, my y is minus 2y. So my b2 is here minus 2. It's a coefficient of y. And then here we have c1, which is a constant term. c1 is 20, and here c2 is 0. Now let us see what is the ratio of a1 over a2. Now a1 over a2 in this case is 3 by 1. b1 by b2 is equal to 4 over minus 2, and when I cancel it, reduce it, I get minus 2. So here I have realized that my a1 over my a2 is not equal to b1 over b2, because a1 over a2 is 3 and b1 over b2 is minus 2. If I get this condition, if a1 over a2 is not equal to b1 over b2, I can say that the lines are intersecting. These are called intersecting lines. Let's get on to the next. And the next one again, let's pick up what is a1, a2. So to find out a1, we must know the x term. This is the x term. And the coefficient of the x term is 4. So a1 will be 4. This is the x term in the next case. And the coefficient of the x term is a2. So this is equal to 2. Now to find b1 and b2, this is the y term, and the coefficient of the y term is 6, so this is equal to 6. Here again, this is the y term, and the coefficient is 3, so this is 3 here. And this is the constant term, this is 18, this is 18 here, and C2 is 9. Now back again, we'll find out what is a1 over a2. That is 4 by 2. So a1 by a2 is 2. Now let's find what is b1 by b2. b1 by b2 is 6 by 3, and b1 by b2 is also 2. Now we get up to c1 by c2. c1 by c2 is 18 by 9, and c1 by c2 is also 2. So in this case, what have we seen? We have got a1 by a2 equal to b1 by b2, also equal to c1 by c2. All the three ratios are the same. And in this case, if we get so, the lines are said to be coincident. One and the same line. a1 over a2 equal to b1 over b2 equal to c1 by c2. Now for the last one, have you seen this is the x term, and the coefficient of the x term is 1. This again for the second one, this is the x term, the coefficient is 2, so the a2 is 2. Now for the b, here this is the b y term, the coefficient is 2, so plus 2. Here 4y, and the coefficient is 4, so b2 is 4. And in this case now we have for c, this is c1, and this is the c2. Now the same way we'll find out what is a1 by a2. a1 by a2 is 1 by 2. Then we find out b1 by b2 is 2 by 4. So b1 by b2 is also 1 by 2. Then we find c1 by c2. c1 by c2, 4 by 12. So c1 by c2, 1 by 3. So we have seen here that a1 by a2 is 1 by 2, which is equal to b1 by b2. So we're taking these values. 1 by 2, we got 1 by 2, and we got 1 by 3 here. But this is not equal to c1 by c2. a1 by a2 equal to b1 by b2, not equal to c1 by c2. And here you know what kind of lines were they? Parallel lines. So if this is the case, our condition is parallel lines. Now just to summarize, we have two lines like this. You know these are intersecting lines. And if they are intersecting lines, how do we know? What is the condition for intersecting? a1 over a2 not equal to b1 over b2. If the lines are coincident, means one and the same, like this, coincident. In this case, we can say a1 over a2 equal b1 over b2 equal c1 over c2. And in the last case, if they are parallel, suppose this line, and we have another line, and they are parallel. Here we will have a1 over a2 equal to b1 over b2 not equal to C1 over C2. These are for parallel lines. Here we have for coincident lines. They are one over the other, coincident. The question can be asked differently. If two lines are parallel, in how many points, two lines are intersecting, in how many points do they meet? Here, 1 point. So they could also ask the question, in how many points these two lines meet, means they're intersecting. If the lines are coincident, in how many points do these lines meet? They're coincident. They will meet at so many infinite points. And if the lines are parallel, in how many points do they meet? They do not meet at all because the lines are parallel. Here, do not meet. Here they meet at all the points. In this case, they meet at all the points. Here they meet at 1 point.